Equilateral triangle ABC has side length root 111. There are 4 different triangles AD1E1, AD1E2, AD2E3, and AD2E4, each congruent to ABC, with BD1 equals BD2 equals root 11. Find the sum from k equals 1 to 4 of CEK squared. Equilateral triangle ABC, which has side length root 111, and we want to find all the triangles which have one vertex at A and are congruent to ABC with another vertex that is root 11 away from B. So it's clear that since all of the other points are the same distance away from A, they're all equilateral triangles with the same side length as ABC, it's clear that all of the other points, both D's and all 4 E's, lie on the circle centered at A through B and C. In other words, the circle centered at A with radius root 111. There are 2 points on the circle that are each root 11 away from B, D1 and D2. One is over here, and the other is over here, between B and C. They're each root 11 away from B, so I will label these each root 11. And now we have to start building equilateral triangles, AD1E1, AD1E2, AD2E3, and AD2E4. Let's start at point D1. There are 2 points E1 and E2 that can be used to form the third vertex of an equilateral triangle at A and D1. Then, instead of doing the direct length computations with the CEs, let's just focus on the arcs they cut off on that circle centered at A with radius root 111. So we can start by letting this arc BD1 equal alpha. So I'll write that here. BD1, the arc is equal to alpha. Then, since ABC is an equilateral triangle and so is AD1E1, that means that this arc here, D1E1, is equal to 60. But so is arc BAC here. That's also equal to 60. So if you go counterclockwise, you'll find that arc CE1 is equal to arc BD1 plus BC minus D1E1. And that's just BD1 plus 60 minus 60. So it's just arc BD1. And that tells us that CE1 is equal to BD1, which is root 11. And now for CE2, that's equal to arc CE1, which we know is alpha, plus D1E1 plus D1E2, which we know are both 60, since AD1E1 and AD1E2 are equilateral triangles. So that's alpha plus 2 60s, which is 120 plus alpha. We can continue to work with more arcs now, with point D2, which is also root 11 away from B, and we have to find arcs CE3 and CE4 in terms of alpha, which obviously is also equal to arc BD2. So first we have arc CE3. I'll do that in blue. Arc CE3, that's equal to arc BC plus arc D2E3 minus alpha. So since both arc BC and D2E3 are 60, because ABC and AD2E3 are equilateral triangles, that's going to be 120 minus alpha. And arc CE4, well, that's just equal to arc BD2 plus arc D2E4 minus arc BC. And the first one is alpha, the second one is plus 60, and the third is minus 60. Because both AD2E4 and ABC are equilateral triangles. They're congruent. So arc CE4 is just equal to alpha, and we know that CE4 equals root 11. So we know at this point that CE1 equals CE4 equals root 11, and arcs CE2 and CE3 are 120 plus alpha and 120 minus alpha respectively. So we can write the sum from k equals 1 to 4 of CEK squared as simply CE1 squared plus CE4 squared, which is 11 plus 11, or 22, plus CE2 squared plus CE3 squared. And we can easily find these CE2 squared and CE3 squared based on the arcs. So if we have points, say, V and W on this circle, then we can find VW squared in terms of their arc, x. Because the radius of the circle is root 111, we have that both AV and AW are equal to root 111 for random points V and W on the circle. So we can say that VW squared is equal to root 111 squared plus root 111 squared, which is 111 plus 111, that's 222, minus 2 times 111, which is also 222, cosine of their arc, which is x, by the law of cosines. So VW squared is just 222 minus 222 cosine x. Now, if V is C and W is E2, then this becomes CE2 squared is equal to 222 minus 222 cosine 120 plus alpha. And if V is C and W is E3, then that becomes CE3 squared is 222 minus 222 cosine 120 minus alpha. So if we add these together, we get that 22 plus CE2 squared plus CE3 squared is equal to 22 plus 222 plus 222. And that's equal to 444 plus 22, which is 466 minus 222 times cosine 120 plus alpha plus cosine 120 minus alpha. We can now expand the stuff in parentheses by using the cosine addition and difference formulas. So first we have cosine of 120 plus alpha is simply equal to cosine 120 cosine alpha minus sine 120 sine alpha. And for cosine 120 minus alpha, that's going to be equal to cosine 120 cosine alpha plus sine 120 sine alpha. And we want to add these up. So the sines cancel, and we're left with 2 cosine 120 cosine alpha. And that's equal to, since 2 cosine 120 is minus 1, we just have minus cosine alpha. So all we need to do is find 466 minus 222 times negative cosine alpha. This is equal to 466 plus 222 cosine alpha. And then we're done. But by the law of cosines, we have that cosine alpha is equal to 111 plus 111 minus 11 over 2 times 111 by the law of cosines on triangle BAD2. And that's just equal to 222 minus 11, which is 211, over 222. So 222 cosine alpha, this is cosine alpha. 222 cosine alpha is just 211. We have 466 plus 211. That's our answer, and it is equal to 677. Thank you for watching my YouTube video, and please follow my channel if you would like to see more videos.